Hello, this is Naz from NB Network Lessons. Hope you all are doing okay. I want to dive into IPv6, IP version 6. As you already know, I've discussed in detail IP version 4. We've gone over different classes of IP version 4 like Class A, Class B, Class C, Class D, and we've done some supernetting also where we have manipulated the mask and derived number of hosts as well as number of networks. But now we want to dive into IPv6. But before we dive into IPv6, we need to understand the hexadecimal numbers, because in IP version 4, it uses the binary numbers, which we've already gone over in detail, whereas IPv6 uses hexadecimal numbers. So we need to understand, how hexadecimal number works, and then after we are comfortable with hexadecimal numbers, we'll go ahead and dive into IPv6. So without any further ado, let's go ahead and get started and look at what the hexadecimal numbers are. So if you look, this is the hexadecimal range: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then after 9 is A, B, C, D, E, F. So essentially, after 9 is 10, which is represented by A in hexadecimal. 11 is represented by B. 12 is represented by C. 13 is represented by D. 14th is represented by E. And 15th is represented by F in hexadecimal numbers. Also, each hexadecimal number has 4 bits. So if you remember, when I was talking about bits can be either ones or zeros or combination of, ones and zeros. Like for example, this right here, 1, 0, 1, 0, okay? So this was, if you recall, I said 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. So in this case, this right here, 2 raised to power 3 is 8, and then 0 is 0, and then 2 raised to power 1 is 1, so plus 1 plus 0. So this binary number right here represents 9. So in hexadecimal number, each hexadecimal number has 4 bits right here, okay? So now let's look into what an hexadecimal number is and how we convert hexadecimal number into binary number. So example is A9. I'm going to start with simple example, A9. That is an hexadecimal number. Okay. A is going to have 4 bits. 9 is going to have 4 bits. Okay. So if I do like this, I know A right here corresponds to 10. So I can write 10. 9 corresponds to 9. I can write this stuff just like this. And now what we want to do is we want to convert this into binary form. So if I convert this into binary form, I get 1, 0, 1, 0, and this is going to become 1, 0, 0, 1. If you are a little hazy on the binary numbers, go back and check my lessons out on binary numbers, and then come back and look at the hexadecimal numbers. It'll definitely help you out. But however, 10, if I convert this into binary, as you know, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, okay? 1, this bit under 2 raised to power 3 is on, so I write 8. 2 raised to power 2, the bit is off, so I don't care. 2 raised to power 1, the bit is on, so I add 2, and then this 0 bit is off, 2 raised to power 0 is off, so I don't care, so answer is 10. So that's how you remember. So now if I want to write down the hexadecimal number in form of binary, this is how I will do it. I will write A9 to the base 16 equal to 1, 0, 1, 0, 1, 0, 0, 1. This right here is the hexadecimal form. This right here is the binary form. Now we want to see what is the decimal number which corresponds to this binary as well as this hexadecimal number. So for that, if you recall, what we can do is we can go ahead and start from right to left. You can say 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, and finally 2 raised to power 7. The bit above 2 raised to power 7 is on, so I'm going to 128. The bit which have zeros, I'm not going to care about them. The bit above 2 raised to power 5 is on, so I'm going to do 2 raised to power 5 is 32. So I'm going to write that down. The bit above 4 raised to power 4 is 0, so I don't care. The bit above 2 raised to power 3 is on, so I'm going to care about that. And rest are 0, so I don't care about that. So if you add these up, 128 plus 32, and I'm sorry, the last bit is also on, so I'm going to care about that. So 128 plus 32 plus 8 plus 1 gives me 169. So we started off with the hexadecimal number right here. We converted that into binary number right here. Then we converted that binary number into decimal number. So now what we want to do is we want to test and see, if we convert the hexadecimal number into decimal number, see if we get the same answer as we got in the case of binary numbers. So let's go ahead and look at that. So now one thing I want to tell you and emphasize again, binary numbers are base to the 2. Hexadecimal numbers are base to the 16. So if you recall, in case of binary numbers, I started from right to left. I said 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, and so forth. In case of hexadecimal numbers, we're going to start from 16 raised to power 0, 16 raised to power 1, 16 raised to power 2, 16 raised to power 3, and so forth. So the number is A9, okay? We want to convert that into decimal number. So A, I know, is 10, 9 is 9. This is from my table right here, the range. So what we do is we multiply 10 times 16 raised to power 1 plus we have 9 times 16 raised to power 0. Okay? So 16 raised to the power 1 is 16. 10 times 16 is 160 plus 9 times 16 raised to power 0 is 1 is going to be 9. So the answer is 169. And it matches with the binary conversion also right here. So the point I'm trying to get across is that in order to learn IPv6, it consists of 128 bits and there are 8 quadrats, and each quadrats have hexadecimal numbers. So that's why it's really important before we dive into IPv6 to understand the hexadecimal number. So what we did was that this is the range, hex range right here. Only thing is that we convert number 10 to A, 11 to B, 12 to C, 13 to D, 14 to E, 15 to F, and represent like this. Okay, and then what we did was that we have A9, a hexadecimal number. What we did was that we said A corresponds to 10, 9 corresponds to 9. We converted that into binary form. And then what we did was that we used our binary range 2 to the base, and then we converted that into decimal form 169. And then we did the same thing. A9 is the hexadecimal number, and we used the